Measurement and motion. Learning objectives. What is measurement? Need of standard units. SI units. Writing symbols of units. Measuring length. Measuring diameter. Motion. Types of motion. Activity 11.1. Measure the length of your table in cubits using your hand. Ask the other classmates of your class to make similar measurements. Do you find the measurements the same or different in each case? Explain the observation. Measurement plays an important role in our daily life. We often come across questions such as how large, how much, how many, how long ago. Measurements are essential to answer such questions. Without actual measurement, you cannot make a correct judgment about the length, area, volume, mass and temperature of a given object. A guess or a rough estimate may turn out to be wrong answer. Look at the two lines given. Which line is longer? Line A. Line B. The line B looks longer than line A. It is difficult to answer this question without actual measurement. Measurements will show that both lines are equal. Thus, measurement is necessary in everyday life. A shopkeeper measures the weight of sugar, rice or pulses. A tailor measures lengths while stitching clothes. If we fall sick, we measure our body temperature with the help of a thermometer. Shopkeeper measuring sugar. Tailor measuring cloth. Doctor measuring temperature. Thus, measurement is very important in our daily life. In this chapter, you will read about some methods of measuring length. What is measurement? Measurement is the comparison of an unknown quantity with some known fixed quantity of the same kind. In our daily life, we make measurements all the time. TH's known fixed quantity is called unit. THE measurement consists of two parts, a number and the name of the unit of measurement. Any measurement is not complete unless both the number and unit are mentioned. Thus, if the length of a bench is 4 meters, then 4 is the number and meter is the unit of length. The length of the bench is 2 times the length of the unit selected for measurement. Similarly, if you have weight 55 kilograms, the number will be 55 and kilogram is the unit of weight. In this case, your mass is 55 times the mass of unit selected for measuring mass. Need of standard units. Long ago, our forefathers used different parts of their bodies to measure length. Such measures of length are still used for rough measurement. The hand span, the cubit and the footstep, width of forefinger were some of the widely used measures of length. Hand span or cubit. Foot span. Hand span of a child. Hand span of an adult. All these units were not reliable because the lengths of body parts are different for different people. For accurate measurement, we need some standard representation of every physical quantity. Such a chosen standard is called a standard unit. Thus, each measurement must mean the same thing to everyone. Therefore, we must use the common units of measurement. Nowadays, standard units of measurements are used for buying and selling various goods. SI units. Scientists all over the world recommended a set of standard units for the measurement of quantities. This set of units is called the International System of Units and the units of this system are known as SI units. SI is the abbreviation of the system International D units in all languages. In this system the standard unit of length, mass and time are meter, kilogram and second respectively. This system is now uniformly used for scientific work all over the world. But in everyday measurements, different systems are still in use. Some of the other systems in use are as follows. The FPS system, in which the standard units are the foot, pound, and second. The CGS system, in which the centimeter, gram and second are the standard units. The MK system, in which the standard units are the same as in the SI unit system. Sci facts. Till the year 1800, various countries devised and used their own system of units. So there were very much units. This is very confusing because a man whose weight is 72 kilograms in Europe weighs 158.4 pound in England. Table. Standard units of length. Length 10 millimeters equals 1 centimeter. 1 meter equals 100 centimeters equals 1 kilometer, km. Writing symbols of units. Carefully look at the symbols of units written in table. The following rules are followed in writing these symbols. Symbols are not to be followed by a full stop. Symbols are never written in the plural. For example, we write 1 kilogram as well as 10 kilograms, not 10 kilograms. Symbols for units are to be written with small letters. Symbols for units named after are to be written in capital letters, example K or degree Celsius. However, when these units are spelt out, like all other units, they are also written in small letters. Measuring length. Length, breadth, height, depth, thickness and distance are all dimensions of length and they are measured in units of length. The instruments used to measure these dimensions are the meter scale and the measuring tape. In making any measurement, we have to be very careful. Otherwise, our measurements may not be very accurate. The main precautions are: 1. Place the scale in contact with the object along its length. Measuring skull by a tape. 2. Place the scale quite close to the length to be measured. 3. Avoid using the ends of a scale for measurements as they are usually worn out. 4. Calculate carefully the measured length considering the length of the scale left out at the worn-out end. 5. Correct position of eye is also important for making accurate measurement. 6. Avoid the substandard meter scale. A standard meter scale has arrows at both its ends. Besides, a stamp of the weight and measures department is also there. A substandard meter scale may have no arrows at its ends or only one arrow at one end. It is usually shorter than the actual scale. Let us learn how to measure length accurately with a meter scale. In our daily life, we use a wooden meter scale for taking ordinary measurements. It is marked in centimeters and millimeters. We will measure the length of a wooden block. The zero mark of the scale should coincide with one of the measuring the length and breadth of a rectangular box. Keep the scale exactly along the length to be measured. It is kept little tilted, the measurement will be wrong. Keep the eye vertically above the end point where the reading is to be taken. The correct position of eye is B, shown in figure. Note down reading from the position B. For a correct reading. Measuring diameter. A meter scale can be used to measure diameter of a round shape object, ball, etc. For it, we have to use two wooden boxes made of thick cardboard with smooth and straight surfaces. Then place a ball between the two blocks such that it touches closely their smooth and straight surfaces. Place the scale along the edges of the two blocks. The distance between their inner edges is the diameter of the ball. Diameter of a ball using blocks. Activity 11.2. Use a thread to measure the length of a curved line up. Make a knot on the thread near one of its ends. Place this knot on the point A. Now place a small portion of the thread exactly along the line. Keep it fixed with the help of both the thumbs or forefingers. Now move the thumb, which is towards the point, a little further so that it takes the position of the other thumb. Again place a small portion of the thread along the next portion of the line. In this way, trace the entire length of the curved line using the thread. Mark on the thread where it touches the end of the line B. Now stretch out the thread on a meter scale. Measure the length between the knot and the mark on the thread. This gives the length of the curved line up. Measuring the length of a curved line with a thread. Activity 11.3. Use a divider to measure the length of the curved line up. Open the legs of the divider to cover convenient distance, say 3 mm. Put one of leg of the divider at one end of the curved line. Put the other leg on the line. Now count the number steps the divider has to take B along the line to cover the entire length of the line. Ab. At the end, if some portion less than the distance between the two legs is left out, being less than the distance between the two legs, measure it separately by adjusting the divider. Multiply the number of complete steps by the distance between the two legs. Add the length of the remaining distance to this length. Motion. What is motion? How can you say whether an object is in motion or not? When the position of an object continuously changes with respect to things around it, the object is said to be in motion. For example, car moving on a road, children on a playfield, birds in the sky and falling raindrops are in motion. Sometimes, it is very difficult to decide whether an object is in motion or at rest. When your friends are seated in a moving scooter, their position in relation to a building changes with time. Your friends do not change position with time. They are said to be at rest. Motion is the change of position of a body with time. With respect to a stationary body, if the position of a body remains the same with time, it is said to be at rest. A person sitting over scooter. We use different words to express motion as 1. A bus runs. 2. A horse trots. 3. The wind blows. 4. A snake crawls. 5. A deer leaps. 6. A fan runs. Running bus. Flying birds. A deer leaps. Running fan. Types of motion. Objects move in various ways. We can classify motion into various types. 1. Translatory motion. When all the parts of body move in the same direction and through the same distance, the motion is translatory. If the body moves in a straight path, then this type of translatory motion is called rectilinear translatory motion. For example, 1. Moving of a car along a straight road. 2. Movement of an arrow shot from a bow. 3. A ball dropped from a height. 4. Movement of a child sliding down a slope. 5. An orange falling down from a tree. 6. The movement of a bullet fired from a gun. A car moving on a straight road. If all the things move along curved line, the motion is curvilinear, circular, translatory motion. For example, 1. Motion of a car along a curved road. 2. Motion of stone tied to a string and whirled around. 3. Motion of the all planets round the sun. 4. Motion of the moon round the earth. Moon around the earth. 2. Rotatory motion. If the body moves round without changing its position from one place to another, its motion is called rotatory. For example, 1. Motion of a top on its needle. 2. Motion of the earth about its axis. 3. Motion of the blades of a fan. 4. Motion of the wheel of a sewing machine. 5. Motion of the sails of a windmill. Earth rotates on its axis. The 21st of March, beginning of spring. The 21st of June, beginning of summer. The 22nd of December, beginning of winter. The 23rd of September, beginning of autumn. 3. Oscillatory motion. The to and fro motion of an object on both sides of its position of rest is called oscillatory motion. Here are some examples. 1. Movement of a child on a swing. 2. Movement of the pendulum of a clock. 3. Movement of a temple bell when pushed gently. 4. Periodic and non-periodic motion. Periodic motion. We know that Earth revolutes around the Earth. It takes 365 days to make one complete revolution. This is then repeated and the process goes on year after year. This type of motion, which repeats itself after a fixed interval of time, is called the periodic motion, Earth revolution around the Sun. Examples of periodic motion: I. The swinging pendulum of a wall clock. 2. The needle of a sewing machine running at constant period. 3. Revolution of the moon around the Earth. 4. The Earth rotating about its axis in 24 hours. Non-periodic motion, motion which is repetitive, but not after a fixed intervals of time, is called non-period motion. It does not repeat itself. Examples of non-periodic motion: I. Kicking the football. 2. Moving a vehicle. 3. Swinging a 5. Uniform and non-uniform motion. When the speed of an object moving along a straight line does not change through the travel path and covers equal distance in equal intervals of time, its motion is said to be uniform motion. If the speed of the object does not remain constant, the motion is said to be non-uniform motion. We can use wristwatch for measuring the time taken for traveling a fixed distance. Swinging pendulum. Keywords: measure, to find the size, length or quantity of any object. Hand span, length in between the thumb and finger of an outstretched palm. Cubit, length between the tip of the finger and elbow. Estimation, forming of a rough guess of something. Standard unit, unit of measurement uniformly considered standard. Rest, when the position of a body with respect to its surrounding does not change with time. Translatory motion, motion in which all parts of an object move through the same distance at the same time. Oscillatory motion, to and fro motion of an object about its position of rest, in which some points do not move at all. Summary: the standard unit of a given physical quantity is an internationally agreed and accepted unit of that quantity. The SI unit of length is meter. 1000 meters is called kilometer. An object is at rest if it does not change its position with respect to its immediate surroundings. An object is in motion if it keeps on changing its position with respect to its immediate surrounding. An object is said to have a rectilinear motion if it changes its position along a straight line path. Rotatory motion is that in which a body moves about a fixed axis without changing its position.